Hello there, this is Professor Eckhouse, and I'm going to talk in this video about order of operations. This is our first lesson video, so I will also talk a little bit about how to take notes. Make sure that you have headings on each section like we have here. Feel free to put what you will learn in your notes. That's a great thing to have at the top. Definitely have the title here. The title at the top, and number of the section. A date is always a nice thing to have too, so you can see what order you did things in. All right, so as you see, there's a list of objectives there. You will review. Normally I say you will learn, but I think most people already have learned these things in the past, but maybe just don't remember them. And if you've never learned them, you might want to take a little extra time on this. So use the book to review this topic more thoroughly, and the thing that I really recommend are these example videos. So as you work through our textbook that we use in this class, you'll see just lots of great videos embedded within the textbook. All right, so we're going to start with combining like terms. So what I normally do if I don't have colors, I'm going to show you with color first, as I'm going to say, well, these two are like terms along with that minus sign right there, so don't lose the minus, and these two are like terms. Now, if you don't have colors and you're just working with a black pencil, and I highly recommend using colored pencils, but you can put, say, a box around these two that are similar, and a circle around these two that are similar. Likewise, you could put dots or other symbols above or below each one. So I'm going to go back to my colors because I like colors and show the like terms. Now that means, and I'm not going to do this every time, but these two right here, 5x minus 2x, those two can combine. And then the 3y and the 7y can combine as well. So these are the yellow ones, and these were the green ones. All right, so 5x minus 2x is basically you have 5 apples and you subtract 2 apples, something like that. You can think about it as they're just counting the numbers of x's. So there's 5x's minus 2x's. And so we get 3x. The same thing with the y. We've got 3y's plus 7y's is 10y. All right, I'm going to turn off my notifications. So I'm going to turn here to presenting so I don't get any more notifications popping up. All right, so that is the final answer. And you can't combine those two things because they are not like terms. One is an x and the other is y. It's like adding apples to oranges. All right, so why don't you try this one? Just pause the video, and I'm going to say this a lot throughout all of these videos this semester, and pause the video, try the example. If you get stuck, start it, stop the video again, keep going on your own, try as much of it on your own as you can. All right, so hopefully you gave that a try. Let's find the like terms. So I've got x squareds, and then I've got x's, and then I've got constant terms. All right, so the yellow one's 3x squared. I'm going to, like I said, I'm not going to do this for the whole semester, but I just want you to see this. The 3x squared minus the x squared. Well, what does that mean? That means minus 1x squared. If there's no number in front of it, it's a 1. All right, and then we've got minus 6x plus 2x, and here's where the colors can really help. Those were the two green ones. And then we've got the purple ones. So we've got plus 8 and minus 1. So those were our two purple ones. All right, so now I'm going to drop the colors and just think about 3x squared minus 1x squared. That's 3 minus 1 is 2. X squared is what we have left. We've got a negative 6x plus a 2x, and so that's basically like 2 minus 6. So we get negative 4x or minus 4x. And then we've got 8 minus 1 is 7. So that is the final answer. Okay. So now we're going to talk about order of operations. So taking notes, you don't have to write every single thing I say, but do write some of it. So I would definitely have a heading for this section, and I would have in some way or another this PEMDAS written down. And you might want to write it down just like this, PEMDAS. Now, can you remember what each one is? If you can't, maybe write it down like it is in the graphic down below first. And then when you're working on order of operations, write it at the top of your paper so that mnemonic can remind you of what to do. All right, so this means we're going to do parentheses first, any sort of parentheses, brackets, and grouping symbols. And there's other grouping symbols we're going to talk about throughout the semester, which I'm going to introduce one down below. And then we're going to deal with exponents. That's the second thing you deal with. So simplify inside parentheses first, if anything can be simplified. Then deal with the exponents. Then do multiplication and division left to right. And it doesn't mean do multiplication first and then division. It means division and multiplication, the two of them, they're the same, basically. Just start on the left and move right. This is the biggest mistake I see, is people think they need to do addition first because A comes before S in PEMDAS. That is not true, and I'm going to show you a different mnemonic down below to maybe get away from that. Addition does not come before subtraction. So you do addition and subtraction from left to right. Just find them all and move left to right doing them. All right, so this might be better than PEMDAS for you. It's a new mnemonic that they're starting to use around the country, and it's GEMS, and G stands for groupings instead of parentheses, because there's lots of different types of groupings, not just parentheses. Then exponents, then multiply, divide, left to right, and then subtract, add, left to right. Notice subtract came first, trying to get people out of that habit of thinking multiplication has to happen first and addition has to happen first. They're paired, and they just happen together, left to right. Okay, so here's your first example. So on all of these examples from here on, I would like to see you simplify yourself and then pause the video and then come back to it. Okay, so give that a try and then come back and see what I have to say. Okay, so I don't see any parentheses. I don't see any exponents, but I do see multiplication. And so this portion right here is going to happen first. So what I often do is I actually just kind of put a parenthesis. So it groups it, and it jumps out at me. I see I'm going to do it first. So I'm going to rewrite this as 10 minus, now 5 times 2 is 10 plus 7. Now here's the mistake that I see a lot of people do. They see addition and think it comes first. It does not. Sometimes it'll give you the right answer, sometimes it won't. So we want to go left to right. Okay, so left to right, and we're going to say 10 minus 10. So I'm going to erase this and get it out of my way. 10 minus 10, I'm going to do this portion first, and I get 0 plus 7. So now we take 0 plus 7, and we get 7. So final answer is 7. So did you get it right? If not, keep trying. Right? Keep work on these a lot. Order of operation takes a lot of practice. A lot of people have gotten into bad habits that were incorrect, and you just need to break those habits. Here's a good one. Give this one a try. Pause the video and then come back. All right, again, no parentheses, no exponents. So we're going to look for multiplication and division because they happen first. So here's one right here, and here's another right there. So we are going to do this and this first. So I'm going to rewrite everything else. I've got 12 minus 7 plus, and I'm going to leave the parentheses just so you can see what's happening here. So I've got 4 divided by 2 is 2, and then I've got the minus, and I've got this other parenthesis. 3 times 2 is 6 plus 1. All right, so there's nothing to do inside those parentheses. There's no exponents outside of them. So we can just erase those now. I just wanted you to see what went where. Okay, so now we're going to go left to right. Left to right. Okay, so I'm going to do this the long way. So 12 minus 7 is 5. All right, then we've got plus 2 minus 6 plus 1. So now I'm going to do the next two. 5 plus 2 is 7 minus 6 plus 1. Okay, notice I'm just carrying these down, right, like that. All right, now we've got 7 minus 6 is going to give us 1. 7 minus 6 is 1 plus 1, that is 2. So the answer should be 2. I see all sorts of answers on these. There's lots of ways to make mistakes. So you just have to use PEMDAS or GEMS and do it in the correct order. All right, try this one. It does have exponents. Okay, so hopefully you gave that a try. So no parentheses, so we don't have to worry about that. The next thing is to do the exponents. So 2 cubed means 2 times 2 times 2, which is 8. And 3 squared is 3 times 3, which is 9. So we get 2 cubed. This one right here is going to be 8 times this one right here is going to be 9. 8 times 9 is 72. All right, give this one a try. Okay, hopefully you gave that a try. This one does have parentheses, so that is the first thing we have to do. We have to simplify the 1 minus 3 and then the 7 minus 12. All right, so 1 minus 3, this portion right here, is negative 2. Now don't get in a hurry here because you'll make mistakes. There's lots of places to make little mistakes. 7 minus 12 is negative 5, and that is squared. All right, so negative 2 times negative 2 is 4. Okay, so we've got 4 minus negative 5 times negative 5 is 25. 4 minus 25. Okay, so these two negatives do not cancel out. You've got to do order of operation and deal with an exponent before you deal with a subtraction. So 4 minus 25 is negative 21, I believe. Okay, let's try another one. This is a good one. All right, so give this a try. Okay, you may or may not know that a square root symbol is a grouping symbol. Okay, so if you had examples up above on this one, a grouping symbol is also a square root or a cube root or whatever root. Okay, so that belongs in the groupings. So in other words, you do what is inside that square root symbol first before you subtract or add or multiply or divide it. Okay, so let's look at this first. 21 plus 4. All right, so I get 21 plus 4 is square root of 25. Don't get in a hurry. The next one I've got, this is separate. The minus is going to come later. I'm going to go ahead and deal with that 2 squared. So 2 squared, 2 squared is 4. Oh my goodness. Come on, black. Minus 4. Okay, so the minus stays. This minus right here, it stays. And it happens at the very end after everything else. Subtraction and addition happen last. All right, the next one we've got 4 times 7. 4 times 7 is 28. And then we've got a minus sign. And we've got negative 1 squared, which is negative 1 times negative 1, which is 1. All right, so we've got 28 minus 1. All right, lots of places to make mistakes, so be careful, be methodical, and take it slow. Square root of 25 is 5. Minus 4 on top. 28 minus 1 we can deal with, which is 27. All right, so 5 minus 4 is 1 over 27. So the final answer is 1/27. All right, so one thing I would like to also mention is that this is also a grouping symbol. It's a division sign, right? That's division is a fraction, right? Top and bottom. But if it's not, we're not going to get decimals from these. We're going to leave them as a fraction. But those grouping symbols mean that we do the top first and then we do the bottom, or we can do it in any order, but we do them separately, and then we can simplify. But this one does not simplify. Okay. Distributive property of multiplication is our next topic. So in your notes, you should have this topic. And if you're using the vertical line method where you have definitions over on the left, you want to put this on the left and the examples are going to go over on the right. Okay, so make sure you get this distributive property of multiplication. That's the rule right there. Okay, so this first one, we have the 3 distributing across this. Erase some of this. And we have the 4 distributing across this. Okay, so let's write this down. So we've got the x, and then we've got plus, and now I'm not always going to do this, but I'm going to do it this time. 3 times 2 minus 3 times y. You could also say plus 3 times negative y if you'd like. It doesn't matter. And then the next one, and I'll do this in a different color so you can tell the difference. So let's make this one green. And so I'm going to say plus 4x plus 4 times 5. I'll put the x in parentheses too. Okay, so there's all pluses there, so you don't have to worry about a negative sign. So be careful with your negatives. You don't want to drop those. So this negative right here often will get dropped. Don't drop it. All right, so now let's work this out and combine like terms. So we've got x plus 6 minus 3y plus 4x plus 20. All right, so I've got x's, and I've got constants, and then I've got this minus 3y that's going to be by itself. All right, so let's put the two yellow ones together. So I've got this x and this 4x. Remember, that's a 1x, so this is 5x. And then constants, usually we write them last. So let's do that last. So we've got minus 3y, and then we've got 6 plus 20 is 26. And let me color code this for you. This was the yellow portion. This was the green portion, and this was the purple. Okay, and that's our final answer. None of that can be combined because they're not like terms. So let me put a box around it. There is our answer. Okay, absolute value. So the absolute value of a quantity is always positive or 0. Absolute value of 0 is 0. Absolute value is also a grouping symbol. So we have one more. We have a fraction bar, we have a radical sign, and we have an absolute value sign. So you can add all of those up above. All right, so the absolute value of A is A, and the absolute value of negative A is A. It makes everything positive. The definition is that is the distance of the number from 0. That's the definition. So it doesn't matter if you're on the left or the right of 0, if it's negative or positive, you're still at that same distance away from 0. All right, so why don't you try this, treating the absolute value bars as parentheses or grouping symbols. So pause the video and give this a try. Okay, so I'm going to look at there's no exponents, so we're not going to have to worry about that. But the first thing we always do is grouping symbols. So we're going to deal with these two things first. So we're going to leave the 2, and then we're going to have the absolute value. 5 minus 9 is negative 4. Absolute value of negative 4. And then we've got 2 times. Make sure they're straight bars because they mean something, right? Make sure it's not just parentheses. 3 times negative 4 is negative 12. Right, so absolute value of negative 12 minus negative 2. Well, let's just go ahead and deal with that. Minus a negative is plus 2. All right, so now let's deal with the absolute value of negative 4 is 4. So on top, we get 2 plus 4. And on the bottom, we have 2 times the absolute value of negative 12. So let me color code this for you. That was our 4. The absolute value of negative 12 is 12. Okay, so that's the absolute value of negative 12 on the bottom, plus 2. Okay, so now remember, this is a grouping symbol. So we want to do the entire top and the entire bottom, and then we will simplify if we can. All right, so on top, 2 plus 4 is 6, and on the bottom, we've got 2 times 12 is 24, plus 2, so hold off on adding that 2 until you've multiplied first. And now we've got 6 over 26. All right, so for reducing fractions, both of those things have a 2 in them. So let's pull that 2 out. We've got 2 times 3, that's what 6 is, and 26 is 2 times 13. So now the 2's are going to cancel out. 2 over 2 is just 1, and we get 3/13. And that's our final answer. Okay, I think that was our last example. So thank you for watching.